All right, so today we're going to start looking at missing dimensions. Okay, so we've talked about volume and surface area of cones and pyramids. Now we're going to look at, well, what about if we know something about our shapes, but not everything? So when we are finding a missing dimension of a 3D figure, we're going to substitute all the values you know into the equation and solve for the missing dimension. So think about what you've done in the past with equations and how we solve them. So question 1 says, find the height of a cone with a radius of 3.5 units and a volume of 77 cubic units. So I know I'm doing a cone and I know I'm doing volume. So first thing I'm going to do is I'm going to write down my formula. V equals 1/3 pi r squared h. Now I'm going to substitute in what I know. I know it has a volume of 77. So V, instead of V, I'm going to put 77. I know it's still going to have the 1/3. I can replace the pi symbol with 3.14. And I know the radius is 3.5. So 3.5 squared. The height is what I don't know. So here's where I need to go through and I need to evaluate these terms and kind of clean this up a little bit. So first thing I'm going to do is I'm going to clean up this 3.5 squared. So if I plug that in to my Desmos, I get 1/3 times 3.14 times 12.25. So that's my first step, is I evaluated that. Now, this is all a big multiplication statement. I can put that in my Desmos, and when I do, it's going to spit out a really long decimal. 12.8216 repeating. And then I have to attach my h. So now I am down to a one-step equation. Now, you're probably asking, well, how do I do that repeating decimal? Well, if you're in Desmos, and I'm going to show you this so you can see what it's looking like. If you're in your Desmos, sorry, and I put in 1/3 times 3.14 times 12.25. If I put in my Desmos, my math, I get that long decimal. Sorry, there's a glare. But I can go down to my next line because I know when I solve this, I need to divide both sides by this repeating decimal. But writing that repeating decimal in Desmos is not easy. So I can do 77 divided by, because I have that, I can put my answer button in. So remember, when you're solving an equation, these two would cancel each other out. So I would end up with 6.005 equals h. And if I'm asked to round to the nearest hundredth, which I probably am, the hundredth would be your first zero. The 5 would tell that 0 to go up. So it would be 6.01 equals your height. So if you were to plug that in for your height, you would see you would get 1/3. And you could always check it. 1/3 times 3.14 times 3.5 squared times 6.01, you get 77.05, which is really, really close to 77. But because you round it, it's going to be a little bit off, but it's still close. All right, so let's do the same thing with number 2. Number 2 says, calculate the height of the pyramid that has a volume of 50 cubic units and a square base with sides that measure 5 units. So you have a square base that's a 5 by 5, and you know the volume is 50. So that means I'm going to be using my volume formula, which is 1/3 BH. Well, to find my big B, I would need to do 5 times 5, which is 25. So it tells me the volume is 50 equals 1/3 times 25 times my height. So I'm going to do 1/3 times 25. So if I get out my Desmos again, let's clear it. Let's do 1/3 times 25. I get 8.3 repeating h. Again, I'm at an equation, which means I would need to divide both sides by 8.3 repeating. So I would say 50 divided by my answer gives me a height equaling 6 exactly. And again, I could plug it back in. I could say, okay, 1/3 times my 25 times my 6 gives me a volume of 50, which is what I want. All right, so let's look at number 3. Determine the length of one side of the base of a square base pyramid that has a height of 3 units and a volume of 49 cubic inches. All right, so since you have volume of a pyramid, we're going to be doing volume equals 1/3 BH. Now, this is asking you to find that side length. So I know for my big B is going to equal the side squared. So if I know the volume is 49, I'm trying to find the B, but I know my height is 3. Now this looks a little weird because these two are away from each other. So let's rewrite it. 1/3 times 3 times my big B. So let's clean that up. 1/3 times 3 is 1B. So that's telling me my big B equals 49. Okay, so if I know my big B is going to equal my side squared, my big B is 49, what squared equals 49? Well, I could say, okay, well, I know 7 times 7 equals 49, so my side length is going to equal 7. And again, I can plug that back in using my Desmos, and I can say 1/3 times 49 times my height of 3 equals a volume of 49, which is what I want. So now let's do our last one. Find the slant height when the surface area equals 72 square units and the length of one side of the square base is 4 units. So this time you're doing surface area. So that's 1/2 LP plus big B. This is telling you that one side of the square base is 4. So that means my perimeter is going to be 4 plus 4 plus 4 plus 4, which equals 16. My big B is going to be 4 times 4, which is 16. Yes, your perimeter and your big B can be the same number. Rare, but it happens. All right, it's telling me my surface area is 72. I know 1/2. I'm trying to find that L. I know my perimeter is 16, plus my big B is 16. So let's clean this up. What's half of 8? Of half of 16? That's 8L plus 16. Well, if I look at that and I'm trying to solve for L, that's just a two-step equation. So I'm going to minus 16 on both sides. So I get 56 equals 8L. Divide both sides by 8. 7 equals my slant height. And again, I should be able to plug that in and get an answer of 72.